I remember how to do this. Good morning. Good morning. Good morning. Good morning. Welcome back to all of you. It's great to see you all in the same space, to see lots of familiar names, and to be back here sharing some invertebrate enthusiasms. It's been a long summer of me accosting people on the river, on the path, on the street, and trying to share some of the discoveries that have been found. And they're like, whoa, dude, what are you talking about? Back away, back away. You're coming in hot with this invertebrate enthusiasm. But here, I'm paid for it. And welcome. So we're going to clear these. Well done. And we'll get underway. The first thing we're going to do is, of course, acknowledge where we are and who we are. And the fact that if you're at the University of Guelph, you're sitting in Canada, and if you're sitting in Canada, you're sitting on traditional, unceded, and treaty lands of First Nations, Inuit, and Métis. And in particular, your University of Guelph sits on the unceded land of the Between the Lakes Treaty Number 3, which is the territory of the Mississaugas of the Credit, which is part of the Dish with One Spoon, which, as you know, is a covenant between indigenous nations to live peaceably on the territories of the Great Lakes. And today it's home to many First Nations, Inuit, and Métis. And your research, our teaching occurs on indigenous land. And we start out the year like this because it's our responsibility to ensure that our activities honor and respect indigenous peoples and lands. And it entrenches our willingness, our obligation to listen. And so this kind of a land acknowledgement reminds us of that collective responsibility to the people and the places where we live and learn. And let's get going. Big things first, right? Why are we here? You're here specifically this morning probably to check the Zoom link, to figure out if you can get up at this time in the morning, and to acknowledge, hooray, most of the days, most weeks on Friday, you don't have to be here at this time, because this time, as we'll get to some of the details, is for you. But really what we're here to do is to proselytize, is to evangelicalize, is to be really excited and to share that excitement and to try and infect others with that excitement about the importance of invertebrates and about the fact that we live in a world where so much is not yet known. And we're in a race. We are literally in a race to discover and to document and to learn from these taxa before they go extinct. So why the importance of invertebrates? At this point, you know this. You can deliver this spiel yourselves, right? The overwhelming diversity, the overwhelming biomass, the fact that invertebrates are more important than vertebrates in ecosystem maintenance, the biology of most things that you run into is not known. Most ants, everybody's going to run into an ant, right? They're a gateway invertebrate, they're a gateway drug. Well, most of those ants are described and can be described or can be identified from only the worker, from only the female. And so if you have a male, probably you can't identify it. So in 2700, you were introduced to the players in the play. In 3700, we dig into what roles those players play and how. Okay. So the outline for today. We'll kind of do some introductions to ourselves. We'll talk about the learning objectives for the course. We'll introduce yourself to where we're going and what we're going to be talking about. We'll talk about the mark breakdown and the assessments, those kinds of things. Simple. And we'll give myself reminders every once in a while. This is Caramel, who is still with us, the 19-year-old super cat. And she's going to peek in every once in a while to remind me to look down at the chat, which you have access to, and to look down at the waiting room, and so that I don't leave anyone stranded outside the door going, let me in, let me in. This is also, Doug is great. Doug turned 5, which is kind of an incredible thing to me that he is 5. But as we talk about invertebrates and we talk about sharing enthusiasms and we talk about kind of moving through space and time, learning from the things that surround us, but also kind of trying to infect others with it, this is a great place that I've found to be infected, to infect others with these invertebrate enthusiasms, facts, videos, that kind of thing. It fills a lot of the gap that some kind of bird-based social media that has gone the way of the dodo But if you're interested, and its icon is an invertebrate. So there are a couple of things that I have built in for you if you wish in Blue Sky. One of them is a starter pack of 150 great invertebrate feeds, people that you can follow, and then a list of, I forget how many, like 300 odd different additional accounts that you can pin if you get a Blue Sky account, and you can follow along with those enthusiasms. If you're going to do it, if you're going to share some things, hashtag it with the class, and remember, when you're out, if you're in any of those kind of like online environments, you don't need coaching for this. You are natives to the digital world, but remember, it's out there forever. So be professional, be positive. Who am I? Who am I? This is me. I'm Alex Smith. This is where I've come from. I grew up in the Ottawa Valley. I grew up on the rivers and streams and ponds and forests of the Ottawa Valley near Algonquin Park, working on rivers there. And then that led me to do an honors degree at Trent University. And I stayed there because of some incredible mentoring and people that I found there, like Michael Barrell. And we worked on amphibians and amphibian decline at Trent for my master's, and then I moved to my favorite city in the world, Montreal, and worked on Lake Erie on the spatial ecology of what we called Bufo fowleri, and what you now know to be Anaxarus fowleri, which is the fowler's toad on Lake Erie. If you've been down to Long Point in the spring, perhaps you've heard them calling in the marshes behind the sand. They make a sound. I'm going to imitate it for you now. Brant, brant. And they are, if you can't see Lake Erie in Canada, you cannot see this toad. And they're an endangered species now. And what do I do at Guelph? I do a lot of things. I look at little things. These are some of the courses that I teach and have taught in the past. And you know me because we were in 2700 together. So you are familiar with my invertebrate leanings. And as Ed Wilson called them, the little things that run the world, that's what I have the privilege of working with. So a lot of my work is in, some of it's where I'm from in Algonquin Park, but the majority of it is in the area de conservation Guanacaste in the northwest corner of Costa Rica, which is an area about the size of more or less, plus or minus, about Toronto, but where we estimate about 3% of the world's species live. This place excites me to no end, and I'm really honored to be able to work there with the people and the species and in those incredible spaces. Other things that keep me excited that you might have bumped into before, we take every week. This is the 17th year of taking the Dairybush Gigapen on your campus. And so that QR code here will kind of take you to kind of look, if you've forgotten about those from 1070, you can explore that. And there are Gigapens, these high resolution panoramas that you can explore all over the world. And I am someone whose soul is invigorated, I think, by being on and near water. And so you might hear about some of those enthusiasms as well. What are some of the other things that I do on campus that you might have bumped into? The Dairybush Fox Den. So we have camera traps around the campus that keep track of some of the species that you are sharing their space with as you move into campus, as you move into the city or return to the city. These are the species that you're sharing the space with. This is a few years ago now, but this is kind of an incredible spring where there were 2 families of foxes sharing the same den. So upwards of 15 different fox kits in that one den. And who else might be around in the spaces behind me? You've seen Caramel, you've seen Doug. This is Lily. There's also Kevin the cat, Special K, who might kind of zoom past in the background. And this is our fam Danley here. And depending on who's at school or not, you might see all of them coming through the background. So what I'd like you to do, first of all, now, is to say, that's enough of Smith. Tell me about you. Find your annotate tool on Zoom and tell me what majors are you in, please. We'll have a moment of silence for the biodiversity major that was never supported enough. And wouldn't it be great if it would be back someday? Lots of zoology, lots of marine and freshwater, some wildlife, and some ecology. That's amazing. All right. I like it. I like how I'm actually really, I'm kind of staring at the zoology panel right now. I'm like, that's a great carpet. I'd like that as a carpet. Okay, so stilos up, lève les stylos, and we're going to clear these drawings, and I'm going to say thank you for doing that, and let's go on. I have more questions. So what year are you in? This is a third-year course, but of course there's going to be a diversity of years around. And we have the category of greater than. Awesome. No, Maddie. Smiley face. Smiley face. There we go. Thank you. Okay. Lève les stylos. Thank you for that. That's great. And let me clear those drawings. More questions. Cards on the table. This is anonymous. Well, it's kind of anonymous, right? But are you more interested in your life, in your enthusiasms, invertebrates or invertebrates? Okay. Wow. This is good. I like it. I will take this as a challenge. Can't choose. Right, big circle in the middle. Amazing. Okay, ole stylo. Let's take those and more specifically, in terms of, and we'll consider aquatic to be also marine in this case. So terrestrial or aquatic environments. What turns your crank? I love the popcorning of the names and the responses. This is amazing. This looks to be close to an even distribution. And lots of, yeah, great. I see lots of literal circles and X's right on the dividing line. That's fantastic. Okay. Ole stylo. Let's go. And we will clear those. Now, so when I talk about familiarizing ourselves with the course and the format, this is literally part of it, right? So we're familiarizing each other with ourselves, and we're sharing, and we're also kind of using Zoom. We're using the tools in Zoom, and we'll be doing some polling later on, but annotate, if you remember from 2700, we're going to use that a lot, at least like a couple times each lecture, to ask questions instead of just kind of being discursive and telling you things. We're going to be asking you things as well. There's other ways that we're going to do it. Some of them might also include other websites like this one. So, the Mentimeter. Let's see if you can go out to open up another browser, www.menti.com, or scan the QR code. Enter 65534518 and tell me about why you're taking this course. And if that's not working, tell me in the chat, please. Oh, I see some of you in there. And the first answer as it jumped up makes me laugh. Awesome. All right, let's move this up here in a second. All right. Lots of you are here because you got to be here. It's part, and that's a reasonable part of an undergraduate degree in biology. I want to redeem myself. I love starfish. Required for the major, mandatory to graduate. Couldn't get into another. Yeah, I love silly animals. I love silly animals too. I mean, I think we're kind of the silliest, but literally all of these ones are just kind of amazing ones. Love for inverts, major course. Nice. Awesome. Thank you for that. Oh, you saw a wild platyhelminth. That's amazing. How was your summer? It was flatworm. That's awesome. Thank you. Okay, then another thing, and you can do this right now or you can do it kind of later on. In fact, I'm going to encourage you to do it by this time next week when we don't have a lecture, but when I would like you, by which time I would like you, I'm kind of keeping track as we go through your career. I've asked you this at the start of 2700, the end of 2700. I'm going to ask you again now, and I'll ask you at the end of the term. But if you can go, the link is in the chat. You can go next week. You can use the QR code. You can get the link later on when you get the PDF of the lecture slides. But I'm interested in what your favorite invertebrate is and to see if that's changing through time. Cool. Awesome. Thank you. So what are the learning objectives for today? To talk to each other, to become familiar with the format, familiar with the course, the content, and familiar with the kind of assessments that we're going to be doing. And so you've already accomplished a lot of that. Well done, you. So the classes are going to be virtual in Zoom, and they're going to be at this time, 9:30 to 10:20, Monday and Wednesday. Why not on Friday? Because on Friday, we've carved off that time for you to use throughout the term to work on the other kind of assessments and assignments that you've got. So two of them that are going to be occurring regularly up until, I guess, roughly the middle of November are these invertebrate R assignments. And so these are assignments where you're going to go into and get raw data in a scenario, real data, and going to evaluate a real world problem. Talk more about that in a few minutes. But it's kind of time for you, if I release a how-to video or an asynchronous kind of a background about some of the scenario, I'll do it on the Friday. But really the Friday is for you to get together and work with those things. There is, in the fall break week, so following Thanksgiving, when our university comes back and has kind of a partial week, there are no labs and no lectures that week. What about the labs? So you should know your own schedule right now, but we're talking about 3 or 4 different segments on Tuesday or Wednesday, and it's going to be in a format of kind of, for each of you, like a 2 weeks on, 1 week off, 2 weeks on, 1 week off. All the labs are in person and will not be recorded. The labs and the classes, the content goes together. And since I said the labs will not be recorded, the lectures will be and posted. Why are we here? What are we doing in this required element, this mandatory part of your degrees? Part of it is this appreciation, this kind of fostered and educated appreciation of the vast diversity of invertebrate taxa. And the other is to use that vast diversity of strategy and taxa and adaptations as a way to parameterize these transferable skills that you're going to use as a zoologist, as a marine and freshwater biologist, as a lawyer, as a parent, as anything that you end up being, all of these different things. The capacity to appraise evidence, synthesize from different streams, and then interpret major patterns. And we're doing it in this scenario of invertebrate diversity and evolution. So with the specifics about respiration or excretion or feeding or diversity or mobility or molting or mating, all of these are themes that we will talk about. Those specifics aren't really the transferable skills unless you end up doing this job. And the unfortunate thing, and maybe one of you will, but the unfortunate thing is there's not a lot of this exact job to be done. But there are many more jobs in the world where your understanding of those verbs and of these cases is really valuable to the world. Oh, I just chatted. It wasn't. So if I might have misspoke. So if you have a lab section on Monday, that's great. I just forgot to write down Monday. That's wonderful, Kira. Yep. No problem. This is not Smith. This is, yep. You've got, your lab sections. The textbook and the lab manual. Lab manual is required. It's posted on CourseLink. You should see it already there. Shayla has prepared that. The textbooks, there's kind of numerous invertebrate textbooks. Some of them are in the library. Some of them are on reserve. Some of them you might have in your hands from taking 2700. and they are optional, but they are helpful. But we're going to be using in this course, as you migrate yourselves in the ontology, your development as a biologist and as a university student, we're going further and further into the primary literature. And so we're going to be using not just the textbook, we're going to be using lots and lots of examples from the primary literature to talk about these things. As a way to excite you, I hope, and to reward that curiosity, but also to renew the impression that you're getting that there's so much that we don't know. There's so much work to be done. There's so much work that you could be doing, but also this is another one of those transferable skills, because this is the primary literature of the invertebrates, and that's vast because the invertebrates are vast, but it's just increasing familiarity and for you, an expectation of you that this is the pool that you're swimming in now, that reading and contributing to that data and being able to evaluate that kind of data is part of who you're going to be now. How to succeed in this course. Come to class and come to lab when you're well and able. Participate in the discussions. If there's kind of things that are going on, Zoom polls, annotation, chats, Mentimeters, those kinds of things, do them, because they're low stakes, right? They're not being graded, they're not being evaluated, and so that's the place to be wrong, is in those kinds of scenarios. Use the Friday class time wisely throughout the term. So today, let's say you're all doing it because we're here, hooray! But in the future, as we start kind of unleashing and releasing these invertebrator assignments, use them wisely throughout the term. The actual assessment is very small. It's only 3 minutes long, but the time to do it is going to be large. And that, again, is kind of a transferable skill, because if some of you go on to doing honors theses or master's theses, what you'll know is that that's kind of a great big funnel of a lot of things that you do, that you funnel into a small opening, and you talk about it, and you share, and you distill down a wide or a deep experience into a small, understandable, digestible nugget. Keep up with the course. We'll talk. I'll try and both Shale and I in the lab will do it where we begin the lab. We'll talk about where this sits in terms of the learning outcomes, like the things that we're going to talk about in each one of our sessions, the lab or the lecture. But we'll also tend to end with kind of this is coming up, and so keep up with those kinds of things as you're going. Caramel reminds me of the chat, and I don't see anything new, I don't think. And so I will keep going. Now, one of the things that's not going away, because it informs all the things that we do, whether we're talking about morphology, whether we're talking about physiological adaptations, whether we're talking about biochemical reactions, as they are distributed around the world, this view is very helpful for helping us express our expectations for novelty when we discover new things. If things are happening in a deuterostome clade or within the spiralians or the ecdysozoans, there's things that we already expect if that trait is being expressed there and not somewhere else. And so it allows us to make informed comparisons amongst related taxa. It also helps us understand the beauty of convergent evolution when the same or a similar trait occurs in taxa that is not because of a shared ancestor, but because of a shared, really stringent environmental condition. So when we think about character evolution and complexity, we can't really answer them without a sound phylogenetic tree. And as we get further and further in resolve these tips, so these are, of course, remember, these are the phyla of the world, right? Kingdom, phylum, class, order, family, genus, species. So lots that remains to be unpacked at the genus, at the species level, lots of important details. But one of the things that we'll find is that this phylogeny, there's a great degree of support for a lot of this tree, not for all of it. And you remember when we talked about tree-based thinking in 2700, we talked about terms that you'll bump into again, like monophyletic and that kind of, and how useful, powerful those terms can be. But there's, even when there are these unresolved polytomies, like here, where we're not quite sure within the spiralians where this group sits, or we're not quite sure within the preoplodes, the loriciferans, and the chinorhynchs, these tiny little ecdysozoan worms, who's most closely related to whom. And if we simplify this tree, so I've taken all the yellow nodes here and I've collapsed them all. You've seen this before. But it's still really productive. And so that a simplified tree is still very useful because it helps us understand and classify based on shared evolutionary history. And so we're going to be using this phylogenetic approach throughout the year. And that is a powerful and transferable skill outside of the invertebrate world that you will get more and more experience with. So what I would like to do now is to take one example and remind you kind of how we do those kinds of things. One of the, there's 2 lectures in a series where we talk about life history, major trends in life history within the invertebrates, and so therefore within the animals. And body size is going to be a thing that we talk about a lot within that. And so here is that done phylogeny with a histogram or a box plot on a log scale of body size for tens of thousands of examples of each one of these, of taxa within these groups. And so what I would like to do, I just launched a Zoom poll, so that's probably popped up, and ask you this kind of a question, because we're going to talk to each other in these kinds of within this phylogenetic perspective in classes. And we're also going to be asking questions in case studies each week and in the exam at the end of the year, according to these kinds of, in this kind of style, let's say. So you've got the questions in and I see the answers are coming in, so I'll zip it. And we're almost up to 50%. Amazing. Awesome. Awesome. So put your right hand up. Pat yourself on the back. This is well done. Thank you for participating. I'm going to pull this up so you can see it and say this one where most of you have fallen. The taxa lacking in symmetry are invariably the smallest invertebrates. That is the statement that is not supported by this in this grouping here. Okay? So what is not supported? So most invertebrate species are small, and so we can talk about each one of these as we go. And I'm going to remind, rather than do that, what I'd like to do is to remind you of some of the elements, some of the that occurred quite frequently in 2700, which is writing these kinds of questions is a really powerful way for you to evaluate the literature and to create a study group. And you can ignore the suggestions to study in groups. That's fine. But there is lots and lots of literature that suggests if you're making these kinds of questions for each other, you're really you're studying well, you're assessing well, you're keeping up, you're going to be in a better place. Okay. Let me see here. I don't see any new questions in the chat. So, particularly in the lab, if you're sick, stay at home. Come to class and lab ready to learn and participate. Be courteous, be respectful. Golden rule. If you have questions, ask. What happens, and these are some of the details, what happens if you miss a class or a lab? First of all, review the posted presentations from the lectures. At the end of each lecture, there's going to be the PDF is going to be posted on the course link. And then following that, only by a number of minutes or hours, will be a YouTube link to the lecture itself. Use the textbook if you've got it. Use the internet. There's going to be citations and QR codes that are posted with all these examples. So to help you explore the literature. Get notes from your classmates. Set up a meeting with the instructor if it's a lab, if you need help getting caught up. The lectures will be recorded, and so that is to give you the freedom that life is complicated, and sometimes you're not going to be able to make it. That's great. The labs, because they're involving samples, involving group work, they're not recorded, and so if you miss those, you're going to need to talk to Shayla to figure out what you can do about that. So if you have questions, ask as many of them as you want. The chat's always going to be open here. I'm going to hang around at the end of each lecture to answer questions for at least kind of a half hour. Those will be the kind of standing office hours, 20 minutes, let's say, at the end of each lecture, if you can. And then if you can't, email me and we can set up another time. There's the discussion board and course link for grading questions. Ask the person who did the grading. If it's the weekly case studies, you can ask me. If it's discussions, presentations, you can ask Shayla, that kind of thing. And the lab reports, that'll be the TA. Now let's talk a little bit about the mark breakdown. There's basically 50% of your grade in the course is going to be associated with the lecture. 50% will be associated with the lab. In the lecture assignment, it's broken down into 3 components, but they each have subcomponents. There's going to be weekly online case studies that are 15%. There's going to be 2 invertebrate R study assignments that I'll talk about in a second, and then there's a final exam. In the lab, there are 3 large components as well. So there's the worksheets that are due weekly in lab to be completed in groups during the labs, and the lowest score will be dropped of the 6. Then there's a lab report that you're going to do throughout the term. So there's a first draft that is evaluated. There's a peer review stage where you provide evaluation. There's a final copy, and then there's how your peer evaluation is itself evaluated. And then there's also, as in the lecture component, there's another video assignment. And this is to try and help you become more familiar with doing presentations and talking to people about the things that you're excited about or you're working on without notes and in a way that shares your enthusiasms. So why have we chosen the assessments we've chosen? So for example, why have we chosen the weekly? Why are some of the assessments like the case studies, why are they weekly? It's to help you keep up with the content. Because I'm thinking about this course, and there's really like 11 to 12 themes that we're going to be doing throughout the term, roughly with the weeks, but not exactly. But because it's an invertebrate course, the mass of examples, the mass of details is amazing and overwhelming. And so if you try and plug it all in at the end, there's really not going to be time or opportunity. It also replaces a midterm, and it helps you because of the case studies will be set up like the final is set up like the case studies. It helps you prepare for the final exam. Why have a lab report? And that's going to give you experience completing experiments as a group, interpreting data, sharing data, providing constructive evaluations, and reporting your results. And why are we having analytical assignments in R? And it's because it's an enormous language for science, and this is an opportunity for you to practice some very transferable skills, to learn how to retrieve, analyze, and present real data using reusable tools and methodologies. And so one of the reasons we've come up with this kind of assignment is really to give you a package of tools that going forward you could then retrieve and use potentially in other courses for projects, that kind of thing. Why do we do group work? These are some questions that have come up in the past. Because one of them is strictly because it reduces the number of specimens used, and that reduces the footprint that we have on whatever live or preserved samples that we have to pull out of the world. It allows you, learning in a group allows you to support each other, gives you someone to work with through your uncertainties. And really, again, it's practicing a thing that we all do as scientists day to day. Science is not a thing done in isolation. It's a group activity where collaboration is the key. So next week, we're going to be talking about zooplankton and Reynolds numbers. So there's some physics involved here, and thinking about viscosity, or inertia, and if you're very, very small, how the world is really quite viscous, and how the bigger you get, the more inertia becomes an effect or an important thing to consider in how you move and how your body's designed. And that's going to happen in the lab as well. So you're going to work in groups 3 to 5, and you'll be provided with a worksheet and instructions. Make sure to bring a lab notebook. Make sure to read through the lab handouts before you get there. You can do that over the weekend or before your lab, whether it's on Monday, Tuesday, or Wednesday. I'm checking in again. I see no other questions here. Oh. I see one question. Yeah, so the lecture slides are posted after the lecture, and I'm happy to talk about why that is, but it largely has to do with the fact that there is lots and lots of research that suggests that enforces the conclusion that learning is facilitated by you having to distill things, that rapidly coming and transcribe. A transcription is not what you're looking for. It's the act of distilling that which you're being exposed to that is uncomfortable, but also in how you learn. Is there a physical lab manual like in 2700 we need to get? So take a look at course link and take a look in the lab section, and you should see, and I believe it's just a PDF. Tell me if I'm wrong in the chat. It's not just a PDF. It's there for you. Let's talk a little bit about the invertebrate assignments. These are 2 of them, worth a total of 15%. So it's 2 analytical assignments that I have centered on aspects of invertebrate biology with a specific focus this year on deep sea vent or deep sea communities, because I find them amazing, because we are learning so much more about them, and because they are under really a particular kind of threat. So you're going to, in the course of these assignments, retrieve from the internet, from public databases, retrieve and manipulate real-world data and analyze it to make inferences and conclusions regarding aspects of invertebrate biology that will then intersect with that real-world development pressure. In each case, we'll talk a lot about deep-sea mining. And in doing so, you're going to be introduced to a methodology and statistical techniques in R that are not just going to be useful to you in this class, that I imagine will be useful to you in many other classes going forward. So, and other transferable skills that are going to come out of this assignment, that we hope will come out of this assignment, include you coming to the end of your the R component, where you're going to create a PDF, and you're going to print the PDF. Like literally, you're going to print some paper, and you're going to use that paper to record a short video summation about your conclusions. Short meaning like 3 minutes. That's a presentation that has to be done without notes, without a script, and it's going to be hard. And this is kind of the point, but it will help you with oral communication of scientific ideas and conclusions in a brief time span. And so the end submission of that is going to be not the PDF, but is going to be your 3-minute video presentation about that analysis. Alrighty. Okay. And that's really about all the things that I had for today. So next week we're going to be talking about zooplankton in the lecture and in the lab. We're going to be, and that is, of course, not a monophyletic group, but it is an enormously ecologically important group, and it has some shared elements of biophysical elements about how it understands and experiences the world. So we'll talk about Reynolds numbers, that kind of thing. What to work on. There's really nothing to work on from the lectures, not a thing. Come on Monday, and we'll see how things go. In labs, when your labs do start next week, so review your Lab 1 materials before attending your lab. Don't forget your notebook, and that's kind of it.